Hi friends, today we are going to discuss about the voltage divider rule and the current divider rule for the Ohm's law or for a DC circuit, you can say. Say let's first find out what's the voltage divider rule. Um, so let's just draw a circuit. Uh, so you can note here that and there is a resistance R1, resistance R2, R1 and R2. That's V and that's I that's going through. So V is the voltage that's applied to the circuit and I is the current that's passing through both the resistance as well as through the whole circuit. Now as you note that the voltage divider rule can be applied to the series circuit, because in parallel circuit, let's say in parallel circuit, the voltage is same across all branch. So if you have a parallel circuit, the voltage is same across all branch, but in the series circuit, the voltage gets divided across the resistance. So let's say if I tell the voltage that's across resistance R1 is V1 and voltage that's across resistance R2 is V2. So how do we find that? So to find this, what I'll do, I'll just use the Ohm's law. So first I'll find the total R value. So R total equals to R1 plus R2. And let's say I want to find, now we just take an example to see like how the numbers work. So let's say my voltage that I have applied across the circuit is 30 volt. My current that I can find out once I have the resistance. So let's say my resistance R1 equals to 10 ohm and R2 equals to 20 ohm. And so what I will do, I'll just use the R total equals to 10 plus 20 becomes 30 ohms. Now here, what would be my Ohm's law statement? That for current, I have to divide voltage divided by resistance total. So I equals to the current that's passing through the whole circuit. Now, my voltage is about 30 volts, and my resistance is also 30 ohms, which gives me 1 ampere current. Okay, so now the thing is that 1 ampere current will flow through the entire circuit. So what I can do, I can apply the Ohm's law to resistance R1 and R2. So for R1, my voltage V1 equal to I divided by R1. Sorry, I think there's something wrong. Just give me a moment. Sorry, it's the other way. So V1 is always I R1, and my V1 is, I don't know, I have to find. So my I is 1 ampere, and R1 resistance 1 is 10 ohms. So that's 10 volt. That's 10 volt is applied to V1. Now let's say we have applied 10 volts to V1, and so for V2 equals to IR2 equals to 1 times 20 equals to 20 volts. And just for a check, what we can do, V total, which is the V that we have applied to the circuit, should always be equal to V1 plus V2. So if you see V1 equals to 10 volt and V2 equals to 20 volt, that gives us 30 volts. That's the total amount of voltage that's been applied to the circuit. So that concludes the voltage divider rule. So now you can find out voltage across any resistance once you have found the current for a circuit. Now let me just move to the current divider rule. So I'll just draw another circuit. So current divider rule, if you remember from the previous case, voltage divider rule applies to a series circuit, where a current divider rule always applies to a parallel circuit. So here I have R1, R2, and R3. I think for the simplicity, I'll just take 2, and I think you can extrapolate to any number of resistance that you want. So I'll just keep it to R1 and R2 for the sake of this example. Again, my resistance is 30 volt. Sorry, my battery is 30 volt. Resistance 1 is what was that? I think it was 10 volt in the previous example. Yeah, it's a 10 ohms. Sorry. Equals to 10 ohms. This one equals to 20 ohms. Now let's say my current that passes through this circuit is I. But as you can see, that current gets divided into I1 and I2. So here you can imagine something like there is a big pipe and there is a water going through this, but as soon as it gets into branches, then some water will go through this pipe and some water will go through this pipe. Depending on which pipe offers less resistance, more water will go through it. You can think a very similar way in this, because in this case it's just the electrons that are traveling. So what I'll do, I'll just first find out the total current I, and that's going to be 30 volt divided by R total. Now for my R total, I have this formula: 1 upon RT equal 1 upon R1 plus 1 upon R2. Now RT equals to R1 plus R2 divided by R1 R2, and so RT equals to R1 R2 divided by 1 plus R2. The total resistance is R1 plus R2 upon R1 R1 R2 upon R1 plus R2. I'll just put the values here. So this one is 10 times 20 divided by 10 plus 20 is 30 equals to 200 upon 30, which becomes 200 by 30 is 6.66. That's 6.66 ohms. That's equivalent resistance of these two parallel resistance. Now my I equals to V upon R total. V I know that's 30 and RT equals 6.66. So this will become 30 divided by 6.66. So that's 4.5 ampere. Now what we know is that this is the total current that's going through this circuit. Now when it gets divided into I1 and I2, we can use the same formula like Ohm's law. So for this branch, and so one thing to note is that this between this junction and this junction, the voltage will remain the same. So the same voltage is getting applied to R1 and R2. So let's say my I1 equals to V upon R1 equals to 30 divided by 4.5, which gives me sorry, I think there's something here. Yeah, sorry, I think I taken the wrong value for my resistance. It's meant to be 10. So that's 10 ampere, and that means I get 3 ampere. So that's 10 ohms. That's when voltage. So this is 3 amperes. I2 will be V upon R2. This becomes 30 divided by 20, 1.5 amps. Now here also you can check when you do I equals to I1 plus I2. This becomes 3 plus 1.5 equals to 4.5 amps. So that's the total current that's passing through this circuit. So let's just divide it by, just give a quick check to my resistance, and so divided by 30, so that's correct. Yeah, yep, that's correct. So this is the way you can deal with a series and parallel circuit and find out the voltage and currents that's passing through the individual resistance or individual branch. So that's a very helpful rules for calculating the voltage and the currents. So yeah, this is the end of this video. I will try to include some more examples in future. So please stay tuned. And if you like this video, please like and subscribe to my channel. Thank you.